In this lecture, we will try to understand Stressen's algorithm based on the idea of divide and conquer. Divide and conquer is a top-down technique for designing algorithm. This technique consisting of three parts. First one is divide one. It divides the problem into smaller subparts until these subparts become simpler enough to be solved. Second one is the conquer part. In this part we solve the problems recursively. And then third one is combine. In combine part we combine all the solutions of subpart to make solution of original problem. Divide and conquer approach can be applied to solve any problem which can be divided into sub-problem. We can say that independent sub-problem. If we divide the problem into sub-problem, independent sub-problems, then we can apply divide and conquer. And we can apply divide and conquer approach at different problem like binary search, merge sort, quick sort, matrix multiplication, etc. We are discussing here the matrix multiplication using divide and conquer approach. In general, the algorithm we multiplying two matrices A and B is fairly simple, although it is more difficult than the multiplying two numbers. Matrix multiplication is not commutative. When, as shown in the diagram in presentation, if we multiply matrix A with matrix B, then resultant matrix is C. If we multiply matrix B to matrix A, then the resultant is C dash. It is not necessary C and C dash is equal. Okay, now we know how to multiply two square matrices. If we have matrix A and matrix B, then the resultant is C. In this way we multiply the matrix and find the resultant matrix. If we want to find out the element Cij, then multiply every element of ith row of A with every element of jth column of B. For example, if we want to find out the element C11, then first element of first row of A multiply with first element of first column of B, then the second element multiply with second element, adding these, and then third element of A with third element of ith row of B, and same way, and adding all these multiplications we can find out the element C11. If we evaluate the time complexity of this method, then we have complexity order of n cube, because for every element of C we performing the multiplication n time, and such n cube elements is there in the C. Suppose A and B of is square matrix. Let us try to find out the divide and conquer approach for matrix multiplications. As we know, we can divide a matrix into smaller submatrices. For example, if A is a matrix of n cross n, then we can divide A into smaller submatrices like this. This is a n by 2 into n by 2 matrix, and this one is also of same n by 2 into n by 2 matrices. and then after multiplication we find out the resultant matrix C. As we see in this example, we performing 8 multiplication, 1 2 3 4 5 6 7 8, and 4 addition. If we try to write the recurrence relation for this matrix multiplication, that one is Tn is equal to 8 Tn by 2 plus additional order of n square. As we know, the addition of two matrices takes order of n square times. If we apply master theorem on this recurrence relation, then we find out the complexity order of n cube. As we discussed above, the complexity of standard matrix multiplication method is also of order of n cube. There is no difference in the time complexity, so we introduce new method. Of course, in order to get faster solution, we have to be looking as Strassen did in 1969. He defined 7 factors: P1, P2, P3, P4, P5, P6 and P7. In the above divide and conquer method, the main component for high time complexity is 8 recursive calls. The idea behind the Strassen method is to reduce the number of recursion call to 7. If we try to analyze these factors, here we performing 7 multiplication, 1 2 3 4 5 6 and 7, and 1 2 3 4 5 6 7 8 9 10 addition plus 1 2 3 4 5 6 7 8, 10 plus 8, 18 addition operations and 7 multiplication operations. So the time complexity of Strassen's method is written as like 7Tn by 2 plus order of n square. If we apply the same master theorem, then the time complexity of above algorithm is to order of n to power 2.8074, that is reduced then order of n cube. Generally the Strassen method is not preferred for the practical application for the following reasons. The constant used in Strassen method are high, and for typical application our standard method is work better. For sparse matrices there is a better method especially designed for them. The some matrices in recursion take extra space because of the limited precision of computer arithmetics on non-integer values. Large errors accumulate in Strassen's algorithm than a standard method. We can see the chart in the next PPT how slightly faster this even for large number of n. Thank you so much.